So welcome back. In this session, we are going to show that the cross product of two vectors, A and B, can be given as a determinant, and then do an example with specific vectors. So in form of a question, show that given two vectors A1I plus A2J plus A3K and B given by B1I plus B2J plus B3K, then A cross B is given by the determinant I, J, K, A1, A2, A3, B1, B2, B3. But that's the cross product of A and B can be expressed in terms of the determinant of this 3 by 3 matrix. So to prove this proof, we'll have to remember a few things we gave in the previous class. So I remember I said that if you have the X, Y system or the axis, then this is the direction, this is how we take the directions using our right hand. So I cross J, you go to K, J cross K, J cross K, you go to I, get I, and then K cross I, you get J. And then when you reverse the order, then you get the negative values. So this, you have to remember this. So we are going to write A cross B in the longest form. So write A cross B means A1I plus A2J plus A3K cross B1I plus B2J plus B3K. And then we open this one in the long form. So A cross B will be A1I, then cross this vector B1I plus B2J plus B3K plus next is A2J cross this vector B1I plus B2J plus B3K, and then plus A3K cross vector B. B1I plus B2J plus B3K. So that's step one. And then step two, let's carry out. Remember A1, A2, A3, B1, B2, B3 are just numbers. So what would be cross multiplied are the vectors I, J, and K. So A cross B will be So this would be now have A1, B1, and then I cross I plus A1, B2, and then I cross J. So remember, cross product is sensitive to order, so you have to maintain that order. And then plus A1, B3, I cross K. So you have done with this part. Plus, so next will be A2, B1, and then J cross I plus A2, B2, J cross J plus A2, B3, J cross K. So I've done with this. Lastly, A3, B1, and then K cross I plus A3, B2, then this be K cross J plus A3, B3, K cross K. Then remember from what we gave last time, I cross I is 0 vector, J cross J is also 0, K cross K is also 0. So it means that then this term, and this term will go to 0 because the cross product of those same vectors is 0. But then now, where there is I cross J, I cross J from this one is K, so this will be replaced by K vector. I cross K now, I cross K the opposite. So this will be negative J. And then J cross I cross J is what gives us K. So J cross I is negative K. So this is also negative K. This negative. J cross K is I. So this one you replace it by I. And then K cross I is J. And then K cross J is the negative of J cross K. So this will be negative I. So it tells us that the next step will be A cross B will be, so if I start with those with I's, I'll have A2, B3I, so this term here, and then minus this one because it's a negative I, A3, B2, I. Let me go for those with J. So J positive is this one here. So I'll have A3, B1, J. This is negative, so negative A1, B3J. K positive is this, so plus A1, B2K. And then this one is negative K, so negative A2, B1, K. So then this can be written as A2, B3 minus A3, B2, I, and then I have A1, B3 minus A3, B1, J. So remember, just when I write this one, this have negative, this will be when you open it positive. So the same thing as this, what I have here. And then plus A1, B2 minus A2, B1, K. So this is A cross B. So this is what I have. But you see, this is not different from writing this as determinant, say I, J, K, and then I put here A1, A2, A3, B1, B2, B3. Because you see this I'm saying A2, B3, A2, B3 minus A3, B2. So using the compact expansion for determinant, so the same thing. So delete this row, delete this column, to get the determinant of this submatrix. So this is a component of R. And then when you are using cofactor expansion, this first element is positive. This one has a negative sign. This one has a positive sign. So negative, that's why I have a negative here. So then close this row, close this, or delete this column. So you have A1, B3, and then A3, B1. So that's why I have this as the component for J. And then for K, delete this column, delete this row. So A1, B2, A2, B1. So this is what we have. And therefore, at the end of the proof. So as an example, given that A is a vector 2i minus 3j minus k, and B is a vector I plus 4j minus 2k, find part 1, A cross B, part B, B cross A, part C, A plus B cross A minus B. So we are going to make use of the determinant definition of determinant to solve this. So solution, A cross B will be determinant I, J, K, and so the components of A, 2 minus 3 minus 1, and then B we have 1, 4 minus 2. And then we find the determinant of this matrix along the first row. Remember, this has sign, positive sign, negative sign, positive sign. So that's by compact expansion. So I'll have I, submatrix obtained by deleting this row, deleting this column. So minus 3, minus 1, 4 minus 2. And this has a negative sign, so negative j. Delete this column, delete this row, so we'll have 2, 1, and then minus 1, minus 2, plus k. Delete this row, delete this column, so 2 minus 3, 1, 4. And these are easy determinants to evaluate because just 2 by 2 matrices. So A cross B will be minus 3 times minus 2 is 6. 6 minus minus 4 gives us 10. And then 2 times minus 2 is minus 4. Minus 4 minus minus 1 is minus 3 minus j gives us positive 3j. This will be 8 minus 3, that's 11. So the answer would be 10i plus 3j plus 11. And then for B cross A, so B cross A is given by I, J, K, then B1, B2, B3, A1, A2, A3, which will be I, J, K. So B1, so this have 1, 4 minus 2, 2 minus 3, minus 1. So that will give us, so remember, we are using cofactor expansion along the first row. So this sign here is plus, sign here is minus, sign here is plus. So that's the first thing to note. So that we'll have I, determinant, delete this row, delete this column. So we have 4 minus 3, minus 2, minus 1, minus j, delete this row, delete this column. So we have 1, 2, minus 2, minus 1, plus k, delete this row, delete this column. So 1, 2, 4 minus 3. So here will be minus 4 minus 6, that is minus 10i, minus 1 minus 4, that's positive 3, then minus, and then minus 3 minus 8 minus 11 times k minus 11k. I hope you can see that this is negative of this, so this is negative of the other, which is as expected from the definition. And lastly, they want us to define a plus b, a minus b. So a plus b will be, so remember a is 2i minus 3j minus k, plus b is 1 plus 1 I plus 4j minus 2k. So when we add the 2, so it'll be 3i plus j, then minus 3k. A minus b will be 2i minus 3j minus k minus I plus 4j minus 2k. So be 2i minus this will be give us I minus 3 minus 4, that's minus 7j minus k plus, so that would be plus k. So I minus 7j plus k. So therefore, a plus b cross a minus b will be determinant I, j, k. So this 3, 1 minus 3, here we have 1 minus 7, 1. So remember the first element has positive sign here. This negative, this is positive. So this determinant will be I. So 1 minus 7 minus 3, 1 minus j And then cross this, we have 3, 1 minus 3, 1 plus k. Delete this, so we'll have 3, 1, 1 minus 7. So that this first determinant would be, so 1 minus 21, that is minus 20i, 3 times 1 is 3, minus 3, that is 6, so times minus j is minus 6j. That's minus 21, minus 1 is minus 22, times k, that's minus 22, k. So therefore, this is the result of that given problem. So thank you.